Effect of friction welding parameters on tensile strength of aluminum 6063 with dissimilar joints. In this paper, the effect of welding parameters of rotary friction welding between aluminum and steel and aluminum and copper are investigated. The major influencing parameters considered are upset pressure, friction time, and friction pressure. The Taguchi design of experiment has conducted to identify the influencing parameters. The tensile test experimentation was carried out, and the results of the aluminum and steel and aluminum copper are compared. Ultimate strength of aluminum and steel joint is higher than the aluminum copper joint was identified, and the increasing upset pressure at 97 MPa and with FP 71 MPa and friction time 4 seconds. On the sides of aluminum 6063, intermetallic compounds have formed as seen in the SEM micrograph. Microcracks are formed on the side of aluminum 6063 and propagate along the grain boundaries. Material selected for this work are aluminum 6063 alloy, EISI 4130 low alloy steel, and copper. The chemical composition of aluminum 6063 and EISI 4130 are given in table 1A and 1B. The properties of copper are given in table 1C. The welding parameters selected for optimization are friction pressure, friction time, and upset pressure. The Taguchi design of experiment has carried out by using L-line orthogonal array. The parameters are given in the table 3. Rotary friction welding has been carried out in rotary friction welding machine. The specimen prepared are shown in figure 2. After the tensile test experimentation, it is found that as friction pressure increases, the tensile strength increases for both the materials, and as friction time increases, again for both the materials, the tensile strength increases. For that, we have also calculated the ANOVA, where the percentage contribution has been identified. The friction pressure is contributing 61%, which affects more on the tensile strength of both the joints. The maximum tensile strength obtained for aluminium steel is 26% higher than the aluminium copper welded joint. The results of the use of AISI 4130, which is stronger than copper and aluminum. The Taguchi and ANOVA analysis reveals the FP influences more on the tensile strength of mentioned welded joint, followed by FT and UB. The SEM micrograph reveals the formation of intermetallic compounds on the sides of the 6063. The formation of micrographs is on the side of AA6063, which propagates along the grain boundaries of R by 2 location. Thus, the failure occurs at AA6063.